and record, and we were backpedaling all last class, so those recordings are probably not good, which is great. You're the second class to go through this. Your session, your lesson today is dense. And even with like my starry-eyed optimism, I couldn't get even nearly a quarter of what I prepared. And I was still thinking to spill some things out as videos. And so one of the cadets had already done some of the problems and he was telling me about them. My guess is you're going to have to probably like take pictures of it and send me a picture if you get stuck so I can nudge you in the right direction. I know you guys probably are used to working with each other to get these done, but it's like there's a lot of content. Okay, so let's talk about the objectives for this lesson. They are nice objectives, but really it comes down to what is it you should be able to do out of this one lesson. And there's a series of things. So if you look at the lesson objectives, it says things like modeling and simulation. But the reality is, at the end of the day, Cadet Lee has to go on a WPR and be able to do something, right? So these are things that are going to be tested on that you have to be able to do. So if you translate it, the first is to use vector, scalar, and symmetric equations. Of lines. Not just use, the first step is getting it. So you know your old y equals mx plus b? There's parametric equations of that. There's something called symmetric equations. There's different ways to express it. And at first it's going to seem like, why would they do this? It's going to become hopefully clear today, like why you would do this. Why wouldn't we just use what we have been doing since second grade? Well, there's a reason. Second, you should be able to use vectors to parameterize a line segment between 2 points. Third, you should be able to use vector, scalar, and symmetric equations of planes. These are all in 3D, by the way, so that we're going to multivariable. And then you should be able to do things with these, like find if you have a piece of paper like angled in the air and you shoot an arrow, it's going to go, and I shot well enough, it's going to go through that piece of paper. You should be able to find that point of intersection. So all the things you did in 2D, got two lines, they crossed, find that point of intersection. Here's a plane, a line, find that point of intersection. Things become complicated in 3 dimensions. If you have two lines and they are not parallel and they're not the same line, they cross into points. You've been doing that since you were little. If you have two planes, we're going to figure out who played with Legos when they were little or not, like 3D. If you have two planes and they intersect, how will they intersect? Let's say they do intersect. What's going to be their intersection? What's it going to look like? I didn't play a lot with Legos. My parents were strict and want me to play at all.
They just be like on top of each other.
That's if they're both the same plane, right? But what if there were different planes? Two pieces of paper slice each other. What's the intersection going to look like?
Like a cross or like a T?
Like, yes, a T, but the place of intersection. You look at this wall back here, or look at this wall here. That's a plane. The ceiling's a plane. The two planes intersect. Not just the corner. That would be 3 planes, right? If I had that wall, and the ceiling, that's going to be a point. But if I had 2 planes, it's a line. So then you have to find the line of intersection of the 2 planes. Does that make sense? So find line of intersection between two planes. I didn't see the three planes, but I'm glad someone brought it up. If you have three planes, typically they should intersect in the form of at a point. But you remember how in the back of the book you could always go, I don't know if you guys even use backup book anymore, dating myself. But if you have a question that says find the intersection of these two lines, there's only two possibilities. One was that they intersected in a point. The other was that three possibilities, I guess. They were parallel and there was no intersection. The answer in the back of the book was does not exist. And then the last possibility is that they were the same line and you say infinite number of solutions. Remember that? Am I bringing back good memories? Here, when you have two planes, it's an infinite number of solutions, but it's got a line of intersection. It's not just any old infinite number. It's this particular line. So you have to actually give that line. If you have three planes, can three planes intersect as a line? Let's now see who's got 3D geometry. Last class doesn't play with the VR. Think about 3D geometry and three planes. Is it possible for those three planes not to intersect at one point? Can three planes intersect at a line? You see it? You could have a piece of paper like this, a second piece of paper sliced through like this. So think of this piece of paper slicing right through, and a third one also going like at a different angle but slicing through the same line. So you could have three planes intersect at one line. So you can have all kinds of stuff happening with 3D. You could have the three planes intersecting at different lines, so they're like a triangle. You could have the third plane slicing through the bottom. You can go play around with note cards to see like all the weird things that can happen. Unfortunately, you don't have time. You have to learn this all in one day. So the next thing is the two hard things, I think, for lots of multi-step things is find distance between point to plane. And then also you could find distance between parallel planes. So as a list of skills, when I pulled out from the objectives of what they wanted you to do, this is what you have to be able to do from this one day. And I look, there's another list, open wide. All right, so I'll pause here if there's questions. I would write this down. Every day I'd try to get out of what your course objectives are, what you should be able to do. Now, there's two approaches you can have to this to be successful enough. One is just memorize all the formulas and spit them back out on the test. If you're going into STEM, that's going to haunt you because you actually do have to know what these things are. Mechanical engineering, any one of the engineering groups, like you're going to have to really know this. Physics, math, it'll haunt you. Because I did that. I learned all the formulas. I'm like, I'm going to get myself through this class and then never see it again. And it just came back again and again and again. So don't do that if you're going into STEM. The other thing is if you understand the underlying geometry, you'll really understand everything. And I only learned that when I taught it for the first time as a grad student at Georgia Tech. Like, wow, if you just read the book and understand the geometry, it becomes really easy. But I don't think I was probably too immature to figure that out. You're ahead of me. Okay, let's get into it.